It is my immense pleasure to welcome our sponsor vScaler to this afternoon's session, HPC in the Cloud Demystified. So without further ado, Glenn Rosenberg, the floor is yours.
Hello Digital HPC Roadshow. My name's Glenn Rosenberg and I'm the Director of Cloud and Managed Services for vScaler. In this presentation, I'd like to share with you some of our ideas and real-world implementations of hybrid cloud. High-performance computing, HPC, touches most computational workloads, and with the drive to utilize AI across all industries becomes more relevant. This is what you typically see when people are talking about the cost variance between on-premise and cloud computing. Cloud technologies have changed the way we look at consuming resources, and this slide shows a story on why moving to the cloud makes such good sense. But it's only part of the story for HPC customers, as they have typically invested heavily in on-premise hardware and how cloud technologies can be adopted to make on-premise the most suitable solution for HPC workloads. This is how we see reality for many customers operating with large computational workloads. They always have an existing hardware estate, a goal to be more agile, be able to run the new workloads, but always be constrained by budget. They also typically want to utilize cloud, they have an AI strategy, and they're looking to reduce the licensing cost or lock in with vendors. Looking at HPC in public cloud in general, we find a number of observations. So the indeterminate interconnect infrastructure can often lead to performance issues, especially with parallel workloads or IO-bound workloads. And this can often be seen variant across different times of day and different days. Costs can be incredibly difficult to understand. And this is the downside of having so much flexibility. As an example, AWS have around 200 instance types that are grouped into 5 categories. Mix that with 55 chargeable services, cost variations across geographies, and multiple prices based on reserving, tiering, spot purchase. And you can see the issue. This becomes magnified when you're trying to run across multi-cloud. Again, this raft of instances also creates complexity in selecting the most cost-efficient solution for your workload. There are costs that are also not hidden, that's the wrong choice of words, but you need to be aware of. There's typically an API call and data request fees, so the put copies, pull gets, etc. And then you have the data movement costs, and that can be across region, it could be across the availability zone, or it could be just moving the data outside of the provider's cloud. So we'd like to rethink private cloud and bring some new ideas to the table. Modern IT has become more complicated. It broadens the demands on the back-end infrastructure, and by simplifying this to create a high level of automation for non-virtual workloads and incorporating static resources into the cloud environment, you can start to make use of the customer's existing infrastructure or allow them to run in the same agile manner with workloads based around virtual machines and about bare metal machines. So allowing people to select the right size resources by any metric, by any type of user for highly specific computational needs allows a greater control of the cost. It also allows the business drivers to take precedent and can be owned by the business rather than being owned by different departments. So a little about the technology. OpenStack started in 2010. It was a joint project between Rackspace and NASA. And the goal was to devise an open standard cloud platform. This was formalized back in 2012 when the OpenStack Foundation was created, which is a non-profit corporate entity. And that means that people cannot make OpenStack close code at any time. It was designed to allow large pools of compute storage and networking resources to be managed through APIs or via a dashboard. And its main advantage is it's an advanced infrastructure as a service, which provides orchestration functionality, fault management, service management, lots of other features, all creating high availability of user applications. And vScaler, which is our product, is a highly developed version of this. We're a verified distribution, so we'll play with all other cloud technologies, but you'll also see us on the OpenStack marketplace alongside the likes of Mirantis, etc. So this is the vScaler software architecture. It's typical as you'd find with any OpenStack cloud infrastructure, apart from the vScaler OS section. But we've run through every single section, and we've either case hardened it, replaced it, or found a way to improve it. We then have this high level of automation, which is our vScaler OS, where we're taking away complexity from the end user, but giving them a very advanced, very performant cloud infrastructure. So we deliver an enterprise-grade OpenStack deployment with a high level of intelligent management. We operate one level down from the latest upstream release. This ensures that all of the bugs and firmware issues are resolved before we release it to our customers. We have our own 1,000-point check validated registry, and this ensures conformance against every other module that's already been released. We deliver this in a containerized deployment, and what that allows us to do is provide rolling updates every 6 months or whenever they're released, without any zero downtime or any need to remove any of the workloads from the cloud environment. We're built upon all of the HPC principles. Our background is HPC, and we provide a high-performant cloud for any workload with no single point of failure. And we also allow for all of the technologies that are being released, so FPGA, IPUs, GPUs, to be used in either a pass-through mode, specifically for the likes of FPGA, or to be used in a virtual mode such as GPU, so that you can use one GPU to many, or if you have a workload that dictates it, run it as pass-through as well. We deliver a high level of automation, harnessing all of the modern technologies and delivery methods that allow the user to run any workload on our platform. And this can be managed at any level within the organization, or can be self-served by the user. We can deliver this in a one box to go vScaler private cloud appliance. This is the latest technology, running the latest generation hardware. It's built around an all-flash storage layer and has RDMA connection right the way through the box. And the benefit of this is that you have your deployment host, your controller nodes, your compute nodes, your hybrid storage nodes, switching, everything all in a single provision. And this is essentially plug and play. So you get it, you plug it into your network, you'd be up and delivering cloud infrastructure within a matter of minutes. But it's much bigger than that. We have the ability to deliver vScaler as you require it across many geographies and whatever resource type that you want to have. So you can start with simple hyperconverged infrastructure in your remote offices, for want of a better term, and then have very specific compute, storage, DPU requirements in different geographies and control them all via a single pane of glass. This allows you to build the resources you need them, and having the option then to burst into commercial cloud allows us to use providers such as AWS for bursty workloads. So that means that you can set for your 70% of regular workload, and when you need that 30% boost, you can use commercial cloud. We run parallel file system, it's distributed file system, we do video, CGI, EDA, we do all of the container technologies, Kubernetes, Mesos, Docker, we have scale out NAS, we run HPC and enterprise applications, Hadoop, big data, object storage, block storage for VM, S3 service provider grade storage, archival storage, HPC backup and eScience. It is really a platform for any type of workload. We have tried and tested tools to allow for a pain-free migration from other technologies to vScaler. This allows the organization to migrate to an open source, cost-efficient, highly performant platform with minimum of interference with their operation. What I'd like to now do is talk about vScaler in the real world. And one of the next topics here that I'm going to talk about is around one of our largest genomics implementation and how we implemented this, taking their existing workloads and moving it into a new environment. So it's a busy slide and I apologize for that, but it shows the complexity in doing that. So we started with part of their new installation running the same OS and scheduler as they've been using in the public cloud. In this instance, it was Ubuntu and LSF. We readied a second cluster and created that with the new OS, converted their tools that they were running into this new environment, but there was still a fear amongst the users that also changing the scheduler at the same time would create added complexity. So the second cluster we created with the new OS, but with their LSF scheduler that they were comfortable running. We then created a third cluster with the new OS and new scheduler. So we moved to CentOS and to Slurm, and we migrated early adopters across until they had a good level of happiness. And then we transitioned over 1,000 users onto this new platform. This means that they now have a very efficient platform, saving them a great level of money, operating in a much more performant environment. We then worked with their researchers to enable them to use new technologies such as Singularity, where they were able to create immutable packages which had all of their tools at the revision levels that they were using at that time. And that's essential for researchers because they often need to go back and rerun their results and findings. But we also opened up Kubernetes, virtual GPU, and all of these technologies as a experimental pad for them, creating a DevOps environment as well. This improved performance by 2x and generated a saving of 7 times without any downtime. So it was a very complex move, but for the organization, it was very important for them. So they're operating with a faster environment, a greatly reduced cost. They have researchers looking at different types of workloads. We're working with them to develop a world-class online platform, and it's been a great success since the implementation. This is an overview of the AI reference architecture that we've developed with NVIDIA. It's based around a DGX2 and our AI management system, offering a cloud environment that's scalable, cost efficient, and a very good AI reference architecture. The white paper is available from our website and is a good read. Thank you all very much for your time. We're now opening our Q&A session using the button on the top right of your screen. Please email me if you'd like to know anything more around vScaler. Email me if you have any questions around any of the comment, any of the statements that I've made, or just email me if you want to comment. Many thanks for your time. Bye-bye.
Glenn, thanks very much for that insightful session. Mez, I'll leave the Q&A floor to you.
Thanks very much. As Glenn said, we have a Q&A tool, so please do pose your questions. I've got one lined up here, Glenn. How much disruption would it cause to move from an existing cloud system over to vScaler?
One of the benefits of vScaler is we have a set of migration tools. So what we would typically do is look at the environment they're moving from and then understand what that is going to entail before we would guarantee the length of time to transfer. But essentially, moving from any public cloud infrastructure to vScaler is quite a simple task. It's essentially down to how the data is located and transferred that adds complexity.
Okay, and we have another question here. Do you allow for some of the OpenStack components to be swapped? For example, Contrail created a Neutron plugin which basically replaces the OpenStack vSwitch with their vRouter that allows for integration to physical network elements such as Juniper routers.
It's a great question. One of the joys of vScaler is that it is based on OpenStack. So having the ability to go under the hood and actually tamper with the engine is something that's always there. So yes, we could either try the product and support it as part of the package, or that would be supported locally by the customer or by the provider. But yes, it's absolutely something that we're comfortable with. I think one of the key points that I was trying to get over in the presentation was the flexibility there is employing an open source product and infrastructure around utilizing a customer's existing infrastructure as well. That generally gives you the ability to sweat assets, but also not to have the cost of rebuilding an alternative rather than utilizing something that's performing well, but then gives you the ability to add the flexibility of a cloud platform to it.